this, 8 randomized trials studying a total of 182 infants, and there were no differences in short-term growth in babies who received the medium-chain triglyceride formulas versus the long-chain triglyceride formulas. There's conflicting data as to formula tolerance and no difference in morbidity, for example, necrotizing enterocolitis. So physiologically, it makes sense to use medium-chain triglycerides, but the studies do not seem to support their use in a very strong manner. Next slide. Carbohydrates used in formulas. Well, here are some of the carbohydrates that we see in formulas: lactose, sucrose, maltose, corn syrup solids, starch hydrolysates, tapioca starches. When we give human milk to a baby, what is the carbohydrate that is primarily in human milk? This one here, lactose. Not sucrose, not maltose. None of those others are in human milk. Lactose is in human milk. Okay, next slide. Well, in the 1970s, Dr. Zantanowicz and Lebenthal did some studies and reported these in gastroenterology. And what they did was they took biopsy samples or autopsy samples of intestine from babies who, or fetuses that died at various gestational ages. And they measured concentrations or activities of various enzymes. And one of these was lactase, and the other was sucrase and maltase. And what they found was that between 26 and 34 weeks of gestation, lactase was 30% that of term, and sucrase and maltase was 70% that of term. And so with this knowledge, it was suggested that we should actually not be giving a lot of lactase or lactose-containing foods to the premature babies. We should really be using other carbohydrates such as sucrose and maltose. Well, next slide, please. This has been looked at more critically in several studies. One of the things to remember is that the microbes in the gastrointestinal tract are able to break down carbohydrates such as lactose, and they break down the carbohydrates such as lactose into 2, 3, and 4 carbon fragments, which can then be absorbed into the distal intestine and colon and be utilized for energy production purposes. Okay, that's called the lactose salvage pathway. But we also have done some studies. Dr. Schulman and colleagues in Houston have looked at what happens with preterm babies, and they've determined their lactase activity using this test called a lactulose to lactose in urine. And they found that early feeding resulted in greater lactase activity at 10 days of age by 100%. And human milk feeding resulted in higher lactase activity than formula feeding. Okay, so putting food into the gastrointestinal tract actually increases the lactase activity, and it's better if you use human milk rather than formula. Next slide, please. So now let's get back to this baby and talk a little bit more about strategy and whether we should be holding off on feeding completely in these babies. And many, many neonatal intensive care units have the attitude that we have TPN available for babies like this, okay? And we can get babies like this to grow on TPN. So why should we put any food in the gastrointestinal tract? Because all we're going to do is cause necrotizing enterocolitis and feeding intolerance. Well, I'm going to go through a little bit of justification why we should put some food into the gastrointestinal tract. Next slide, please. This is a summary of a paper that I did fairly recently, and there's some references in there. But no food in the gastrointestinal tract leads to TPN-associated sepsis, mucosal atrophy, lack of trophic hormones, systemic inflammatory response syndrome, decreased mucosal IgA from Peyer's patches, and increased adhesion molecules and PMN attraction. You attract too many white blood cells or a lot of white blood cells to the intestine, all you're asking for is trouble. Next slide, please. Now, this is Dr. Elsie Widdowson, very famous scientist from Great Britain, And many years ago, in the 1950s, 1960s, she did some studies showing that in the pig, the newborn pig, that the duodenum gains 40% of its weight in the first 24 hours after birth. If that animal is not suckled with the milk, this does not occur. So no food in the gastrointestinal tract, that growth of the duodenum does not occur. Next slide, please. Studies done in Houston by Owens and colleagues looked at the enteral versus parenteral intake. And here you see enteral intake as a percent of the total intake. So that they were giving, these are piglets now, they were giving only IV nutrition over here, and this is more enteral intake over here, okay? They looked at the weight of the intestine and the protein in the intestine and also the DNA. Not until these animals were getting about 30 to 40% of their intake through the gastrointestinal route did they start seeing some increase in the mucosal growth. Okay? So it takes around 30 to 40% of the intake through the gastrointestinal tract to actually get mucosal growth. However, remember that mucosal growth is not everything. A trophic effect on the gastrointestinal tract is not everything. There are several studies now that show that even small quantities, 2-3 milliliters per kilogram per day, increases various trophic hormones from the gastrointestinal tract. Okay, and also I'll show you some other data here that is that shows that putting food into the gastrointestinal tract can be very important. Next slide. This is another study that looked at TPN. And this is again in animals versus enteral feeding, and here they're looking at portal blood flow. Okay, TPN, low portal blood flow, enteral feeding, nice normal portal blood flow. Next slide. What about superior mesenteric artery flow? Okay, these were animals that were just started on enteral feedings initially, then placed on TPN. Here's what happens with the superior mesenteric artery blood flow. Okay, concern here is that putting food in the gastrointestinal tract actually steals blood from the gastrointestinal tract. No, it does not. Putting food into the gastrointestinal tract increases blood flow. Next slide. Barrier function is also important. Putting food into the gastrointestinal tract can improve barrier function. If you don't have very good barrier function, you can have translocation of bacteria or other substances in the gastrointestinal tract that can cause systemic inflammatory response syndrome, which may not only injure the intestine, but also injure other organs as well, such as the brain and the lung. Next slide, please. When you look at permeability, this is a study in animals, piglets again, looking at lactulose and PEG. These are markers of permeability. Okay, and lactulose is a sugar that passes through between the intestinal epithelial cells. If you have a leaky intestine, you see more lactulose. Here with TPN, more lactulose than with enteral feeding, more PEG with enteral feeding than with parenteral feeding than with enteral feeding. Next slide, please. This is a study that looked at the liver after 7 days of TPN versus enteral feeding. Okay, here's enteral feeding, nice normal-looking liver with normal-looking histology. Here's parenteral, very gray-looking liver with abnormal histology. Next slide, please. What about parenteral nutrition and bacterial translocation? Okay, we know that we usually think of sepsis in premature babies as coming through the intravenous lines. Well, I think that there's an alternative hypothesis that's becoming more and more popular, that a lot of the sepsis that we see in premature babies does not just come through the intravenous lines, but through the gastrointestinal tract. This is a study that was done in adult animals by Dr. Wildhaber and colleagues, where they gave adult rats a control feeding. This is just giving them normal food through the gastrointestinal tract. Another group got TPN alone, and another group that got TPN plus food. And what they looked at was the number of microorganisms that translocate through the gastrointestinal tract. In the control situation where the animals are eating normally, really no translocation. TPN, a lot of translocation. Giving them the TPN, in other words, having the line in, plus feeding them, resulted in a marked decrease in translocation of bacteria. So what this is telling us is that the major factor responsible for TPN-induced bacterial translocation is the lack of enteral feeding and not the administration of the TPN solution itself. Next slide, please. Now, those were animal studies. Here's some more work done in human premature babies, where they looked at permeability of the gastrointestinal tract and using lactulose mannitol ratio, giving a little bit of food from day 4 to 14 versus TPN only to day 15, and looking at these babies at 10 days of age, you see that the group that gets the TPN has more intestinal permeability, a leakier gastrointestinal tract. And here they look at the carmine red transit time, in other words, how fast food moves from the upper gastrointestinal tract out into the stool. And here you see that if they are, if they got GI priming, it moves a lot faster than if they had TPN. But the important thing to remember is that the GI priming versus TPN took place in the first 15 days of life. That was where they looked at this. But they're measuring this at 6 to 9 weeks, considerably later after this period. So this effect lasts for a long period of time. Next slide, please. Minimal enteral nutrition, usually defined as getting less than 20 milliliters per kilo per day, results in improved feeding tolerance and growth, less need for phototherapy, decreased cholestasis, decreased osteopenia, gastrointestinal trophic hormone surges, improved motility, and no increase in complications such as necrotizing enterocolitis. And this is summarized from about 12 studies now. Next slide, please. So in summary, the GI tract of the premature infant has several immaturities related to anatomy and function that do not allow immediate introduction of full enteral feedings. But we can have strategies that we can use to safely utilize the GI tract depending on its developmental status. Next slide. And finally, remember that a gut is a terrible thing to waste. Thank you for your attention.